In this example, it is asked to find the parametric equations of the plane passing through the point P node with coordinates x naught, y naught, z naught. So this is the point P node with the coordinates x naught, y naught, z naught, containing two parallel vectors, the vector A with components A1, A2, A3, and the vector B with components B1, B2, and B3. So these two vectors are parallel to the plane, not parallel to each other. And we're asked to use that information to find specifically parametric equations of the plane that passes through the origin and contains the vectors I minus j and j minus k. Now let P be a point with coordinates x, y, z on the plane, and using the parallelogram law and choosing two scalar quantities u and v that are positive, so u and v are scalar quantities, that are also positive, we have that the vector P node P will be equal to u times the vector A plus v times the vector B. And if we consider two position vectors R and R naught that point at the point P and P naught respectively, then the vector P naught P is equal to the difference between the position vectors R and R naught. And this is equal to u times the vector A plus v times the vector B. And therefore, the vector R will be equal to the vector R naught plus u times the vector A plus v times the vector B, where the u and v are real numbers. If we write the position vectors R and R naught in terms of their components, we have that for the vector R that is equal to the vector with components x, y, z, and for the vector R naught is equal to the vector with components x naught, y naught, and z naught. And also we have that the vector A is equal to the vector with components A1, A2, A3, and for the vector B is equal to the vector with components B1, B2, and B3. And we can therefore rewrite the parametric equations through the point P node with coordinates x naught, y naught, z naught as follows, that x is equal to x naught plus u times a1 plus b times b1, and y is equal to y naught plus u times a2 plus v times b2. So we use the x and y components of the vectors, and for the z component we have z equals to z naught plus u times a3 plus v times b3. Now these are the general parametric equations, and we're asked to use those parametric equations to find parametric equations of the plane that passes through the origin. So the point P node will have coordinates 0, 0, 0. So the point P node will coincide with the origin, and the vector A, so we have that the point P node has coordinates 0, 0, 0. The point P will have coordinates x, y, z. Now, the vector A, we are given that is equal to the vector I minus the vector j. So the vector A will have components 1, minus 1, and 0. And the vector B has components j minus k. So it will have components 0, 1, and negative 1. And therefore, substituting all that information In the parametric equations, we have that x equals to 0 plus u times 1 plus v times 0, and therefore x is equal to u. Y is equal to u plus u times the negative 1, so a2 is equal to negative 1 plus v times 1, and therefore y is equal to v minus u, and z equals to 0 plus u times 0, so a3 is equal to 0 plus v times b3, which is equal to negative 1, so v times negative 1, so z is equal to negative v. And therefore, these are the three parametric equations of the plane that passes through the origin and contains the vectors I minus j and j minus k.